Now, there's a ton of other adjustment cost models you can come up with. You could use A times absolute value of K dot. Now, that is going to have some different properties, right? Because what is this? What's going to be different here? Think about it. There's going to be A is going to be the marginal cost of going up and marginal cost of going down. So there's going to be a whole region of inactivity, right? There's going to be a region where it doesn't pay to go up because I got to pay A to go up, but I don't want to go down either because I got to pay A to go down, right? So it's going to have this kink in it at 0, but it also doesn't have any rising marginal cost either. That is, if I want to go 4 miles an hour for an hour or 2 miles an hour for 2 hours, it costs the same, right? It costs the same because there's an absolute value here. So the absolute value of 2 plus the absolute value of 2 is equal to the absolute value of 4. It doesn't really matter how fast you go in this model. It just, you don't want to go up and down. But if you're going up, you might as well go as fast as you want. Now, you could combine these models. You could make it so that you have rising marginal cost and this kink. You can make it so you have a fixed cost of adjustment, which is, it costs me something to adjust at all, and I just have to pay a fixed cost. Now, in that world, what would you want to do? Well, a lot of times you don't want to adjust, but if you're going to adjust, you might as well adjust a lot because you already paid the fixed cost, right? So there's a lot of models you can build. The far and away, the one that we've seen people use the most is this kind of quadratic adjustment cost model.